Hello, my name is Michael Goldfarb from Side Effects Software. Welcome to this introductory video on rigging in Houdini. In this introduction, we'll be giving a rigging overview. We'll talk about Houdini digital assets. We'll talk about the difference between objects and geometry. We'll look at parenting, hierarchies, and general transform order. We'll be looking at bones and nulls. We'll look at animation controls, constraints, rotation order and gimbal lock, naming conventions, mirroring, and then we'll have a brief look at rigging and animation scripts. In part 1, we'll create our HDA, and we'll start working on our spine using the Path tool, Bones tool. We'll use Follow Curve IK. We'll create controls. We'll create some proxy geometry, and we'll do our HDA parameters. In part 2, we'll look at the left arm. We'll be using an IK with twist. We'll make some controls, constraints. We'll create proxy geometry. We'll make our HDA parameters. We'll look at matching IK and FK, and we'll mirror the arm. In part 3, we'll be doing the left hand. We'll be doing expressions. We'll be creating controls, proxy geometry, our HDA parameters, and we'll be mirroring the hand. Then in part 4, we'll do the left leg, very similar to the arm with IK with twist. We'll make some controls. We'll look at constraints, make proxy geometry, build our HDA parameters. We'll use matching IK and FK scripts, and then we'll mirror the leg. In part 5, we'll finish up with the left foot. We'll do a reverse foot, the controls, proxy geometry, HDA parameters, and again, we'll mirror it. And then in part 6, we'll do a final sweep of our HDA, cleaning up any odds and ends, things that aren't named properly, stuff like that. And then we'll take a brief look at animation scripts that you can put onto your HDA to give your animators more control. Rigging in Houdini is like rigging in any other DCC app. You're creating a structure that you can attach your geometry to, and then a control hierarchy that you can use to drive that structure. In addition, you're creating a user interface that the user, usually an animator, can interact with. In Houdini, much of this functionality can be wrapped up in a single node that is used like any of Houdini's other tools. We call these Houdini digital assets. You might also hear the term OTL. This stands for Operator Type Library. When this functionality was first developed, one of its cool features was the ability to bundle multiple assets into a single library. While this is still possible, the common workflow these days is to have a single tool inside a single library, and so the terminology has been updated to reflect this. If I mistakenly mention OTL, it's because I'm an old dog that hasn't learned this new trick. Some of the useful features of HDAs for character rigging are the ability to protect your rig from unwanted alterations or outright deletion of nodes. And you can see that this tool, our soldier, has been locked. And that means the user can go inside and look around, but can't alter anything here. You can see that everything is slightly grayed out. With HDAs, you can expose only those parameters, those controls that you want your user to interact with. This is called promotion or promoting a parameter, and we'll be doing plenty of it throughout this tutorial. These interfaces are created by using what's called the type properties. And this dialog allows you to use all of these parameter types to add them to your rig. You can see all the parameters that we've added to our soldier rig. In addition, many of these parameters can have what's called a callback script. So if a user presses a button or makes some change to a parameter, a script can be called. In this case, clicking this button will set all to default. And those scripts are handled here in a Python module. And we can add that script here. So when the user clicks that button, it'll run this script, and that script lives here. Additionally, with HDAs, you can store extra files. And these can be anything. In this case, all of these are the proxy geometry for our rig. And you can see that these are binary, they're geometry files. You can also store textures and extra scripts, all kinds of things in this extra files area. And we'll go through that as we go through the tutorial. It's important to understand the difference between objects and geometry. This difference might seem obvious, but in Houdini, these are very different things. Let's consider 4 objects: a null object, a camera object, a bone object, and a geometry object. So what is it that makes these objects different from each other? If we dive inside each of them, we'll see that in each case, we're in the geometry context and have access to all the regular geometry tools. So why have so many different objects? Beyond the fact that each has a different type of geometry, mostly for display, each of the different geometry objects has a different set of parameters, and this changes their behavior and use. The null object is just a transform that has something inside it to look at and select, but it would still perform its function if it was empty. The camera object also has a set of transforms, but there are two things that make a camera differ from a null. Number one, the display geo is shaped like a camera. But two, most importantly, it has two sets of parameters that send important information to both the viewport and to the renderer. The bone object also has a set of transforms, but also two sets of parameters that are particular to rigging. The first is on the bone tab. Here, rest angles are stored, the bone length, the kinematic solver, and other parameters. Secondly, on the capture tab, lots of parameters having to do with the capture region and capture pose. And finally, the geometry object. Like all other objects, it has a set of transforms, but importantly for geometry, it has a set of parameters dealing with how geometry is displayed, shaded, and rendered. When creating a rig, we'll mostly be dealing with creating relationships between objects, mostly nulls and bones. So let's just take a simple look at how that's done. Here I have a simple null and a box. And right now the null is at -2 in x over here, and the box is at the origin. If I want to parent the box to the null, I can just wire them together. And that will move the box to be a child of the null. So now I can translate the null and the box will follow. But what if I wanted the box to stay where it was and still yet follow with the transform of the null? Well, I can do that by turning on Keep Position When Parenting. Now, when I parent them together, the null will keep its position when parenting. But there's no free lunch with transforms. So in order to establish the relationship between these two objects, while keeping their relative distance from each other, a transform has to have gone somewhere. If we look at the null, nothing has changed here. It's still -2 in x. And if we look at the box, its translations, local translations, haven't changed either. So where did that transform go? If we middle-click on the box, we'll see that its world transformation is the identity, but its pre-transform now has 2 in translate x. You don't have to worry about these exponential notation. These are just zeros. So the box has been transformed into the space of the null, and then before its local transform, it's been moved 2 units in the x-axis in order to stay that relative distance apart. If I wanted to get access to that pre-transform, I could come here to the Modify Pre-Transform dropdown, and I could say Extract Pre-Transform. That will take that pre-transform value and put it up in our local transform. And now when I middle-click, I'll see that my pre-transform is none. My world transform is still identity, but here in my local transform, I have a 2. And if I have this, but I wanted to shove that down into the pre-transform, I could just use this Modify Pre-Transform again and say Clean Transform, or in this case, Clean Translates. So now that takes that 2, shoves it down into the pre-transform, just as we had before. But let's say, after having established this relationship, that I'd like this null to be closer to the box. But how do I do that without moving the box and without having to redo the establishment of this relationship? Well, something that I can do on the null is I can turn on temporarily child compensation. So if I turn that on, watch what happens. I can move the null. The box isn't moving. And now I can turn child compensation off. And now when I move the null, the box moves with it. So what happened there? As we said before, you don't get a free lunch. The transform relationship between these objects has to be correct. So where did that transform go? If I look at my null, I've moved it in x to its new position. And now if I look at my box, it's been moved in x to compensate for its parent having moved from here to here. And again, you don't have to worry about this scientific notation. These are just super accurate zeros. And if I middle click, you can see that it has no pre-transform, world transform's identity, but it's been moved to compensate for its parent moving. And child compensation and key position when parenting have no relationship with each other. So that's why key position when parenting being on or off in this example makes no difference. We'll be looking at all of this more closely as we go through the tutorial, but it's important to have a basic understanding of these things, because when you're trying to figure out where this torus is, and where this guy is, and what this guy is doing, you need to understand the relationships between the local transform, the world transform, the pre-transform, and constraints. So if we look at this torus, it has a local transform, and it has no pre-transform and no constraint. So you would think that this is where the torus is, but it isn't, because it has a parent. So this local transform is relative to its parent, but you can see that its parent has a pre-transform, so it's not where it's telling us it is, and it also has a constraint. So the torus is the result of this rotational constraint and the pre-transform of its parent's local transform, if it had any, its own pre-transform, in this case none, and its local transform. So having a basic understanding of how these things are related is going to be quite important. But just be sure to remember that the transforms have to be somewhere. And you can find them just by especially middle clicking will tell you lots of information. Following the hierarchy, looking for this little guy, this little green wavy icon, that will tell you that a constraint is active on this object. So hopefully that will at least give you some basic understanding of how all of these things are related to each other. And it's good to know to track down any kind of issues. We've seen that nulls are really just transforms with something to see and select. They are also often used as control objects that our animators can interact with. If we look at the null itself, by default it comes in just as this little cross type thing. But if we go to the miscellaneous tab, we can see that we can do a number of things here. We can change its color. We can assign a select script. But we can also do things like change its size, scale, center, rotate, display, and control type. Now this scale is purely a visual thing. It has nothing to do with the actual scale of the object. It's just scaling the control SOP inside. Additionally, we can display this null as different kinds of things. So right now it's as an icon, but we can display it just as an axis, if that's useful, or an icon and an axis. Additionally, the control type right now is set to null, the default. But we could set it to circles. We get this kind of a thing. And then we could also choose the type of plane that we wanted. Right now it's all planes, but we could say Y and Z, or just these two. So we have lots of options there. Similarly, the box is just a box. We could turn on shaded mode. That overrides how the viewport displays this object. The planes also has a variety of types to choose from. Then we can combine some of these things. So we can have a null and circles. Looks like that. And we can go in and change the planes that the circle displays. We can also do a null in a box, null in planes, and finally we can say control SOP input. Now right now that leaves us with nothing in the viewport, and that's because we have to go inside, and we can see that this control object has an error. It's because it needs now an input, because it's been set to control type custom. And so to fix this, we're going to provide it with some incoming geometry. And that geometry can be really anything that you want. In this case, I'm going to use a torus. I'm going to make it much smaller. And then I'll just feed it into the first input of this control object. And now you can see in the viewport that we have a torus being used as our null. And if I go up to the object level, I can select that, and now That's our null. This in particular may not be very useful, but you can see that I could use just about anything I wanted. So if I wanted to make a custom curve to represent some kind of control on my rig, I would just go inside here, make that custom control, and then feed it in to the control object. Go up to the top level, select Control SOP Input. Bones, of course, are going to be very important in rigging. And a little feature of Houdini's bones that I'd like to point out to you is the following. If I put a bone down in the network, it will plop itself right down there on the origin. And its pivot is here at its root, at the thicker end. And in the network, if I hold Alt and click and drag to duplicate this bone, now I have two bones sitting on top of each other at the origin. And if I want to make a hierarchy of these bones, I can just simply parent them. But watch what happens in the viewport when I do this. Just move over a little. This second bone, instead of parenting to the pivot of the first bone, it places itself at the tip of that bone. And so this is obviously what we would want, but it's nice that the bones are sort of aware that if they're parented to each other, that they should just follow along like that. For our control hierarchy, we'll be using nulls, taking advantage of the different types available by default, like the box or the sphere, which lets us create simple circles on any of the three axes. But we can also use custom shapes by drawing curves or using other types of geometry, such as spheres and lines, and setting the control type to Control SOP Input. By default, objects have a rotation order of X, Y, Z. You can change this if you need to using the drop-down menu on the Transform tab of the object's parameters. Bones, on the other hand, have a rotation order of Z, Y, X. This is to ensure they behave correctly with the IK solvers. If you need to change this, you can use the Edit Parameter Interface selection from the Gear menu, and at the top, Show Invisible Parameters. Then look for Rotation Order. Now this parameter will be available on the bone's parameter pane. Note that changing the rotation order on a bone can result in unwanted behavior when using the IK solvers. Another way to create relationships between objects is to use constraints. Houdini uses chops-based constraints, introduced in Houdini 16. Constraints can be created using one of the shelf tools in the Constraints Shelf tab. The type of constraints we'll be using most of the time is the blend. With the blend constraint, we can create the types of constraints more familiar to those coming from other applications, like the parent, point, and orient constraint. You can enable or disable gimbal mode by right mouse button clicking on a handle and selecting gimbal mode. With gimbal mode off, Houdini will ensure that you see 3 rotation ring handles, and when you rotate a ring, the other rings will rotate with it, despite the rotation order. When gimbal mode is on, Houdini will display the true positions of the rotate handles. Dragging a rotation handle will change the rotation components directly, without Houdini trying to fix gimbal lock. Gimbal lock occurs when 2 rotation axes overlap, making it impossible to rotate them independently. This can cause problems in animation when it can seem like rotations no longer have the intended effect. Houdini's handles have a gimbal mode that controls how the rotations work. Before we start on our rig, let's see what our final result will be. We'll be making an HDA to contain our entire character as a single tool. It will have a full interface for all the controls we want to expose to the animator. Our rig will have an eye look at with individual eye constraints. The eye look at will have space switching, allowing it to follow the head or the world, and an optional eye line to help the animator know where the character is looking from a distance. The head will have space switching as well, and a simple jaw control. The spine will employ a hybrid approach, using an IK spine driven by FK controls. This will allow the freedom and flexibility of an inverse kinematic solution, but also the direct control of forward kinematics. The arms will use both IK and FK in a single chain, with functions to match IK to FK and FK to IK. The IK wrist control will have space switching, separate clavicle and scapula controls. The hand will have individual controls for the fingers, as well as controls for all the fingers together. The legs, like the arms, will have IK and FK in a single chain, and will implement a standard reverse foot setup, which will include foot roll, heel offset, a ball offset, toe pivot, heel twist, toe twist, side to side, and toe rotation. All of these parts will have functions to set all of the parameters back to default, as well as setting keys. Many more such functions can be added to a rig, but I'll just be demonstrating a couple to show how these kinds of features can be implemented. That's it for this overview. Join me in the next video where we'll be building our HDA and starting on our spine.